So we've got 4 sections chock full of good stuff. And chapter 3, we already started talking about how we're going to solve systems graphically by seeing where they hit each other when we graph them. Now we want to do this for what the class was designed for, which is algebraically. You know, this is Algebra 2. We're supposed to be able to do these algebraically. And graphing, historically, that was the first way that they solved these problems because they didn't have algebra when they first started trying to solve systems. But eventually somebody said, okay, this is not real accurate. You know, it's not working out. Sometimes they hit in the right spot, but if we're not perfect with our graphs, then maybe they don't. And so they develop algebra so they could be a little bit more accurate. And in 3.2 it says, we are going to solve a system of linear equations using substitution, and I can solve a system of linear equations using the elimination method. So there's 4 of them here, and 2 of them are covered in this section. This is a big deal. So pay close attention today. If when I ask a question, you're like, I know that. Well, then help out. Let me know what you're doing. So what we're doing is we're going to focus on the algebra today. And that algebra starts right here with an example as we look at our objective, solving systems algebraically. And it says, what whole dollar amount of one-day sales would make it more worthwhile to work at store B and justify your reasoning? There are a lot of jobs out there. And what you want to do if, you know, there's a lot of jobs for the position that you can hold, is know which of these is going to be the best for me. It's not necessarily the job that's closest to your house. It might be the job that pays much more. So in this one, this is something with sales commissions. And it says for store A, you only make $35 per day. But you get 10% commission on all the sales. So obviously this must be something really big. Nobody's going to say, yes, I'll take that job, 35 bucks a day. No. So it must be something like large items like cars or something that costs a lot of money. So I started thinking, for store A, their income comes from $35 plus 10% commission on the sales. Well, they don't know what the sales are, so I don't know what the sales are, but I know they're going to make 10% off of it, and 10% as a decimal is 0.10. X will be my sales. So this would be store A. Store B, even worse, 10 bucks per day. Good golly, that's hardly nothing. But with that store, you can earn 18% commission on all your sales. So you start thinking, why does a business want to do this? You know, why would a business say, we'll give you $35 a day plus 10% of your sales? We'll give you $10 a day plus 18% of your sales. Because like I said, they're selling big ticket items. These are things that cost thousands of dollars, and they want them to be sold. I mean, that's what they're doing. So what they're really doing here at store B is they're saying, you know what? You're almost working for free if you don't sell some stuff. I mean, that's what they're saying. And that's part of the process in any sales job, is understanding that you have to become really good at selling things in order to make a decent buck. So this wants to know what whole dollar amount would make it more worthwhile to be at store B. Well, then we would want to know, when is this going to be greater than this? And that's math we can do. So I'm not actually even going to finish that one up today, because the big piece of this that we have to get to is the setup that I have here for those equations for A and B. If we can do that, then we can figure out where the algebra will take us from there. And like I said, these are things that happen every day in different jobs that involve sales. Now, problem 1 is going to take us through the process of solving by substitution. So if the name is substitution, I think, well, at some point, obviously, we must take something and put it into an equation. And that's exactly what substitution does. So it says, what's the solution of the system of equations? The first thing I want to look for if I'm going to use substitution, because later on we get to choose, we don't get told which one to use, is I'm trying to find something that would be super easy to solve for. So I want an x or a y or a negative x or a negative y, because I can get that by itself really fast. And I see this. And I realize all I would have to do to get y by itself is just subtract 2x from both sides. So there's kind of like a step 1/2 here where we ask ourselves, is this a good one for substitution? And this is a really good one for substitution. So step 1 with substitution is always to try to get one of the variables alone. It doesn't matter if it's x or if it's y. You just want one of those variables all alone. So solve one equation for one of the variables. Now, like I said, that's usually a decision we make. On the test, we will have one problem that says solve by substitution, so you have to use substitution for that problem, and another one that says solve by elimination, so you don't have a choice. But in most cases, you get to choose which one you want to do. So I go back to this bottom one, and I subtract 2x from both sides. And I have y equals negative 2x plus 10. Now here's why that's really important. I just found out what y is. I didn't get a number answer yet, but I know it's negative 2x plus 10. So now I can do step 2. Substitute the expression for y in the other equation and solve for x. And while you're writing that down, I think I'm going to get a cough drop so I don't start coughing all the way through this lesson. Anybody need more time to write that down? All right, so what I'm going to do, since y equals all of this, is take all of this and put it right there, right behind the 4. So it's going to say 3x plus 4 times negative 2x plus 10 equals 12. And this is what I've been getting at all year. You should look at that and say, well, I know how to distribute, and I know how to get x by itself. Hey, I know how to do that now. So just by using a couple of quick steps, we get this to be something that we have solved before and we have seen. So what would be the first thing you would do? Yep. Now your thoughts. Combine like terms? Is that what everybody's saying? Yeah, let's combine like terms. Because now we're down to a 2-step equation at this point. Took a couple steps to get there, but we're down to a 2-step equation. Then what's left? So we have x by itself. Yep. And we're going to leave that as 28/5. Now, I think, woohoo, I'm done. And then I remember, oh, hold on a minute. I'm trying to find the point where these two lines hit each other, where they crisscross. That's only one coordinate. I have more work to do. So when we substitute, we get one answer, but then we have to substitute again. That's why this is called the substitution method. We're not quite done. We haven't found y. We need x comma y. So I look around and I'm thinking, boy, I'd like to put that in the easiest, fastest place possible. And I could go back into one of the original two if I wanted to. But look at this one. This one is literally solved for y. Well, I'm going to use that one. We said y equals negative 2x plus 10. And I forgot the negative. I thought I wrote it. Maybe the smartboard didn't like it. And I know x is 28/5. Now, here's what I want to remind everybody. If the fractions are starting to scare you a little bit, remember, you've got this. This will take care of it for you. So negative 2 parentheses 28 divided by 5 parentheses plus 10. Math number 1, enter. Don't even have to do that part in your noggin if you don't want to. I'm going to show you how to, but you wouldn't have to do that in your head if you didn't want to. So this would be like a 2 over a 1. Top times top, bottom times bottom. So negative 56/5. And now I have 10 over 1, and I realize I need it to be over a 5. So I'm going to have to multiply the top and the bottom by 5, and that would give me 50/5. And y will equal negative 56 plus 50 would be negative 6/5. Now, this last step probably won't be worth a lot of points on the test, maybe like a half a point. But what we have to do is say, we realize these were two lines and they hit each other at one point, so we have to write this as an ordered pair. 28/5, negative 6/5, and then maybe put a star by it or box it or something like that, so that you know this was the answer, pulling it all together. Two lines that hit each other. Now, sometimes we give you a point and we say, hey, is this a solution to these systems? To be a solution to the system, it must work in both equations. Or even if there's more than two equations, 3, 4, 5, it must work in all of them. So it has to work. And again, that's something really fast you could do, because we've got 3x plus 4y equals 12. So you do 3 times 28/5 plus 4 times negative 6/5. And that has to come out to be 12. And then we had 2x plus y. Oh, and I forgot the 4 in front of the y up here. I said it and didn't write it. And that has to come out to 10. So that writing that down is probably going to take longer than it will for you to pop it in your calculator and make sure it works. But that's all we have to do, is put it in the calculator and make sure it works. 3 parentheses 28 divided by 5, parentheses, plus 4, parentheses, negative 6 divided by 5, parentheses, enter. It's good, but it's not enough that it's just working in one. It has to work in both. 2 parentheses, 28 divided by 5, parentheses, plus parentheses, negative 6 divided by 5, there's 10. And now we're absolutely certain. You know, there's no question. And that's what we should have been doing when we were graphing too, but since our graphing calculator will graph the two lines for us and Blinky tells us exactly where they hit, most of the time we just say, Blinky knows what he's doing. He's found me the right answer. Well, that was one problem. You substitute not once, but twice, and you get both your x and your y. So let's take a look at this one. Now, I want you to do the little analysis part you're going to have to do when you get to the homework here. Is this a pretty good problem for substitution? What makes it a pretty good problem for substitution? What could we get by itself really fast? Yeah, that little x up there. So step one is we took a peek at it and we saw that if we just subtract 3y from both sides, we'll have x all by itself. And it doesn't matter if you write it as 5 minus 3y or negative 3y plus 5. It makes no difference. So there's step one. And then we have to do the name of the process. Substitution. We have to substitute. So I just used the top equation to get this. That has to go in the bottom equation, because we have to use them both at the same time. So the bottom one says negative 2, and we just said x equals negative 3y plus 5 minus 4y equals negative 5. Again, now that's something we can do. We've done that before. That's not new math. So you go ahead and do yours out there. I'll do it up here, and let's see if we all end up in the same place. Good, I was just eavesdropping real quickly on a few papers, and already I saw a lot of people already had that done and had it right. So the next thing I do is say to myself, self, was there a nice easy place for me to put that y and get x back very quickly? And I remember this little bugger in the red right over here. Yeah, because this would make it calculator work. I can just put negative 3 times 5 halves plus 5 in my calculator. I got to write it down, of course, because, you know, I got to show work on the test. But negative 3 times our little 5 halves plus 5. Again, if you want to do it with the calculator, do it with the calculator. If you want to do it in your head, do it in your head. So this would be negative 15 halves, and I would have to change 5 into halves. So my 5 over 1, I would multiply the top and the bottom by 2 and get 10 halves. And y would be negative 5 halves. I put that on the test, and when I get my test back, I go, oh, I can't believe I did that. Because what did I just forget? Why isn't it done? Look at the last problem. What's not quite finished? I mean, it's totally, just a little bit short of finishing. What's wrong with it? We were trying to find the ordered pair, the coordinates, the x and the y. We got to write them down. Oh, and this one was x, and I went ahead and wrote y. Gosh, I'm having trouble writing stuff today. There we go. So we write down -5/2 and 5/2 and put a big star or a box or something. And if we did want to check this with the graphing calculator, you know, let Blinky find it for us. Blinky always does the decimal thing. So Blinky would tell us -2.5 and 2.5 as we go through there. But we need to check. Even if we just write it down and then we pop it in the graphing calculator, we still have to check. Hey, Xander, we didn't get very far. That's good. You're going to catch most of it. So x plus 3y, -5/2 plus 3 times 5/2 is supposed to come out to 5. And then -2x, so -2 times -5/2 minus 4 times 5/2 is supposed to come out to -5. Again, you can do it by hand if you want to. Most people at this stage, they're like, I just did all the thinking before. I'll let the calculator do the checking for me. So parentheses -5/2 parentheses plus 3 parentheses 5 divided by 2 parentheses. Hey, it's 5. That one's good. -2 parentheses -5 divided by 2 parentheses minus 4 parentheses 5 divided by 2 parentheses -5. It's good. So to make sure it works, it has to work in both. It has to work in both. And it did. So we've got it. So that's substitution. But it wouldn't be all of substitution if we didn't do what it's intended for, which is word problems. And that's what we're going to do next with problem 2 here, is figure out, okay, how does somebody use this to find pieces of information that are missing? And this would definitely be one where I would hope people would say, I wonder how much that is. So using substitution to solve a problem, we've got a music store that offers piano lessons at a discount for customers that buy their new pianos. So if you buy their pianos, then they give you this and say, here, this is how you can start those lessons. The cost for lessons and a one-time fee for materials, includes the music books, the CDs, all the software, all that good stuff, are shown in the advertisement. What is the cost of each lesson and the one-time fee for the materials? That's what you'd want to know as a parent, or maybe as you're taking the lessons yourself as a consumer, you'd want to know, how much is this? So this one says 6 lessons, and I realize, well, I do know how many lessons, I just don't know how much each of those lessons costs. So I'll have x equal the cost of the lesson. They said that's not all you have to pay. In addition to the 6 lessons, you also have to pay a one-time fee. I don't know what that one is either. I'll have that be y. For all the materials. And what I do know is how much that comes to. So if you do the 6 lessons plan, how much do you have to fork over? Right there in the ad, bold, orange, 300 smackers. So then I see, well, the other one's $480. Oh my gosh, $480. What do you get for your $480? 12 lessons. We still have to pay that doggone fee, don't we? Got to have the music books. Is this a good problem for substitution? It's a really good one. We have 2 choices. It's up to us which one we want to have solve for y. So let's all do this the same way so everybody's paper can match up. It won't matter. You'll get the same answer in the end. But just so our papers are the same as we're working through it. You want to solve the red one for y or the green one? Up to you. Nobody cares. Well, then let's solve the red one for y. Just because it's the first one. So we'll subtract 6x from both sides. Well, that wasn't too tough. Where does that go? Where does it go? I know some of you are already doing it. Yeah, and the y in the green one. I think I ran through this one last night without a calculator, and it wasn't too bad. But you realize, well, this is just a placeholder here in the red. I mean, I just need to do 12x plus a negative 6x, which is 6x plus 300 equals 480. Then I got to subtract 300 from both sides. And divide by 6. I better think about what that was. What was X standing for again? Yeah, so each one of these lessons is going to be 30 bucks. That wasn't the only thing I was supposed to find, was it? So think about it for a second. What else did we have to find? And here's the good news. That's what this is built for right here. This red one over here. All we have to do is put that 30 that we just found in the green. And yeah, if you didn't want to do any of that in your head, you could just go ahead and use a calculator, but you'll get negative 180 plus 300. We're getting some fancy materials, aren't we? You know, they said software and all that kind of stuff. Now, in the other two problems, I made a point of saying, hey, the two lines are hitting, it's a point, we need to give the coordinates to the point. Not for word problems. And that's because they asked us really specific things. And we want to know the cost of a lesson is $30. The cost of the one-time fee, or the one-time fee, I think everybody would know that that's going to be a cost. So the one-time fee is $120. So with word problems, you can just write a quick short sentence or two that says, hey, this is what I found here. An ordered pair doesn't make sense because they asked us specific questions. Well, that wasn't too bad. So we'll do another one of these and you'll help me out a lot more. So we're looking for those two equations so that we can use substitution and solve them. So that doesn't look like a big scary word problem. Looks kind of little. It says an online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. So this is really, really similar to the piano lessons. What's the cost of each download and the registration fee? Well, I've told you before that when I do a problem, I try to think totals. I don't know about you, but I saw that 1975 right away and thought that is a total. So what am I going to get from a 1975? Do we know how many downloads or how much a download costs? Okay, so we're going to have to do it. I'd really like to use D. You want to stick with X and Y or D and F? Downloads and fee. Let's use D and F this time since we used X and Y. We have to pay the fee, right? No matter what? All right. Did you see another total up there? Yikes, 43.50. Whew. So what do we get for our 43.50? 40 of those downloads. Yeah, and again, we don't know how much they cost. We just know it's going to be times 40. And do we have to pay the fee with 43.50? Yeah, we have to pay it both times, don't we? Okay, make a decision. Because we have two of them here we could solve for F, right? You want to do the red or the green? The green. We'll do the green this time. Uh-oh, that doesn't look like a 4. My mask is getting in my face today. You know, when they slide up into your eyes, you're like, what am I doing? How can I see? Must not be tight enough if it's doing that. Well, what do I do with that? Plug it in. There's the substitution thing. So this has to go in the red because we haven't used the red yet. Right up there for F. So 15D plus, in parentheses, I've got my negative 40D plus $43.50. And that has to come out to 1975. And yeah, we're going to be working with some decimals this time, but you know, real world, that's what happens. So we take 15D minus 40D, and we get negative 25D. Let me put it up here so everybody can see. There it is. What should we do next? Subtract 43.50. And this is where some of us are really grateful we have these calculators with today to make these things a little bit faster. Negative $23.75, which can make you a little nervous because it's a word problem and you're like, negative money doesn't make sense. But in the next step, what do we have to do? Yeah, so the negatives are going to be gone anyway. So there's my negative 23.75 divided by negative 25. 95 cents. What did D stand for? Does that make sense? I mean, nowadays it doesn't, right? Because, I mean, they give you whole complete packages for $10 a month or whatever, but it makes sense that, you know, it'd be a pretty cheap download. So we're done? What haven't we found yet? The fee. And here's my green F right up here. We found this 95 cents. And let's see what we'll get. Oh, I forgot the decimal. That would have been really bad. There we go. I accidentally pushed a negative. That's what it was. $5.50, one-time fee. And then, like I said, because it's a word problem, and I know I didn't give myself enough room, I better try and move some of this down a little bit or something. We should just write a little short sentence or two. Each download costs 95 cents, and the one-time fee, my M is getting away from me here, is $5.50. So we've answered everything they needed. They wanted to know how much are those downloads, how much is that one-time fee going to be. So that's substitution. But sometimes substitution isn't the easiest and the best way to go. Now, if you don't mind fractions, then substitution could be your go-to all the time. But if you don't like working with fractions all the way through, then we look for another method. And this method, this book calls elimination. Many other books call it linear combination. And here's what that one says. Well, I could get one of these x's or one of these y's by itself, but there'd be a lot of nasty little fractions in there. I don't really want to do that. But I just noticed something. Do you see how this one has a positive 4x and that one has a negative 4x? I wonder if I could just add those together and find an answer. And you can. You can. So 4x plus negative 4x is 0. That cancels out. 5y equals 25. Divide by 5. See, Jerome, why didn't you show us this one before? That was so fast. Well, because now it takes more time to get the second one. So with substitution, you do all the work to begin with, and then it's super easy to finish it up. With this, the first one's usually kind of easy. And then you have to say, this has to go back into one of those two. Don't care which one, but one of those two. So I'm going to use the top one, and I'm going to put the 5 in. So I'm still substituting, just not as much as with the substitution method. And like I said, I have more work I have to do for the second variable. So this will be 4x plus 10 equals 9. And I will subtract 10 from both sides and divide by 4. X equals negative 1/4. Not done yet, though. Because step 1 was look for opposites. Oh, you know what? I probably should just let you move the box and let you write those down. Now, I know step 1 says add the equations, but we can only do that if we have opposites in either the x's or the y's. So as we get going on this, we're going to find out that sometimes we have to make that happen. Sometimes we have to make opposites. And then step 2 says solve for the remaining variable. That's going to involve substitution. We're going to have to plug it in to either of the original equations. And then just like we did earlier, we would take our nice ordered pair of negative 1/4, 5, and we would plug it into both of them and make sure it works. So while you guys are writing that down, I will plug this in up on the TV up there so that you can see this is going to work. So we should check after we do these and make sure the x is good, the y is good. And I've got it right up there for you. -4 times -1/4 plus 2 times 5. That's the top equation. That came out to 9. It was supposed to. And down on the bottom, -4 times -1/4 plus 3 times 5, which is 15. That comes out to be 16. And then we would write that down. And put a check by it to show that we know it works. But really, it's as easy as popping it in the graphing calculator and just making sure, do I get the number that's on the right side when I do this? Now, like I said, this one, they made perfect for us. The 4x and the -4x, those were already opposites of each other. So they're doing that to give us kind of a baby step. But we know that we can multiply any equation, every single term, by a number, and it will be equivalent, so it'll give us the same answer. So even if they're not, we can multiply by things that will make that happen. So, trying to wait and make sure everybody had all those steps written down that they wanted on there. Add the equations, solve for the remaining variable, substitute to find the other variable, and check. Anybody need more time? We set? All right. This one. I want you to look at it as if it were a problem on the test that didn't tell you which method you would want to use. Would you want to use elimination with this one? What do you see there that makes this a good elimination problem? Exactly. It doesn't matter if it's the x's that are opposites or the y's that are opposites, as long as there's a set of opposites. So, we could add these two together. And then you start thinking, well, that went a little fast, didn't it? Well, that's why it was set up for elimination. It's supposed to go fast for the first variable. So we have the first one. And we have to decide if we want to put it in the top equation to get the other one or the bottom one. You like one of those better than the other? If you're saying it doesn't matter, it doesn't. It absolutely doesn't matter. Are you putting it in the top or in the bottom? Well, you put it in the top, then I'll put it in the bottom. We should end up with the same answer anyway. I should color code. We get to this step and somebody's always going, I think we did something wrong. Are we done yet? We're not done. 20 minus 20 is a number. It's 0. Just keep going. Keep seeing what you get. 0 divided by -8, that's 0. 0 happens. It's a number. It just kind of throws us sometimes when that happens because we're like, shouldn't this come out to some kind of fraction or something? And then there's our ordered pair, which of course we would check. -2 times 4 plus 8 times 0 equals -8. Well, of course that makes sense, because 0 times 8 is 0. So yeah, that'll be -8. That's good. And then 5 times 4 minus 8 times 0 equals 20. Of course it does. 5 times 4 is 20. 8 times 0 is 0. Boom! Didn't even need a calculator for that one. It's looking good. Now, like I said before, these are set up super nice for us. So the question becomes, what do we do if they don't give us opposites? I mean, do we just go with substitution and work with fractions? Try and solve the top one for u or v or something like that. what we are supposed to do if we're using linear combination or elimination is try to figure out what we could multiply one or both of the equations by to get opposites. So I'm looking at this, 3 and -2, thinking that'd be pretty good. Because I could use 6 if I multiply by 2 up here, and 3, and that would be -6. Those would drop out nice. And then here, 3 and 3, oh, if I just multiply one of those by -1, that'll drop out. And so now you start thinking, well, which method is better? It shouldn't make any difference if you do the math right. I'm going to do it the easy way. I'm going to multiply that bottom one by -1, because it already has a bunch of negatives anyway. And remember, that just makes all the signs the opposite of what they were. I'm going to leave the top one alone. Like so. And now, I have 3v and a -3v. And those will cancel out. Now, like I said, if you looked up there and immediately thought, I'm going to get 6u and -6u, I'm going to multiply this top one by 2, this bottom one by 3, the u's will drop out. If you do it right, yes, absolutely. But try to pick the easiest way. So now when we add these, we will get 5u equals 20. Well, let's just divide both sides by 5. And u is 4. And again, you get to pick which of those top two you put it in. Usually I will say go with the one that has the least amount of negatives, because again, those are the most common mistakes that we make in math. So 3 times our little u value of 4 plus 3v equals 15. Well, 3 times 4 is 12. We'd subtract 12 from both sides and divide by 3. And then we go, how are we supposed to write that as an ordered pair? Because isn't it always supposed to be x comma y? Well, it turns out it doesn't matter what two letters you use as long as you put them in alphabetical order. So you think, oh, W, X, Y, U, V, W, X. Oh, U comes first. You can sing the song if you have to. That's kind of fun, too. A, B, C, D, E, F, G. But it's always alphabetical order when we put them in an ordered pair. So they might not use X and Y for every problem. Well, that worked out pretty slick. And that is a good place for us to stop. Now, what I tried to do was go a little bit farther than I normally would, because tomorrow and the next day, I'm going to try and give the tests back. Remember the test we took? I know it was a long time ago now, right? But we took a test. Let me double check on that one. It's like it says finish 3-1, but we finished 3-1 on Friday. So I'm thinking this might be split into 2 separate assignments. That was the one thing I didn't look at this morning, was what is the assignment on there? Yeah. All right. Sorry, erase. That's too much for what we did. Unless you want to do all those. Okay. The rest of this is just review. There we go. That's better. 10 through 19. 21, 67 to 71, and 75 to 80. The last two broken apart with commas there, those are review problems. Again, remember to show your work so I don't have to write little messages on Schoology and then you think, why didn't I get the points for that? Because I give you the answers. I want you to just copy them down. I want you to do them yourself. All right, substitution, linear combination, definitely our goal. Solving the systems using those. I'll have to make sure that that's changed on campus and Schoology.